Okay, law of sines notes. So far in trig, all we've been doing is been working with right triangles. Okay, but what about other types of triangles? Not every triangle is a right triangle. The other type of triangle is called an oblique triangle. An oblique triangle is basically any triangle without a right angle. Okay, so we're going to be working with ones that don't have that little box. So before we needed that right angle, that 90-degree angle, now we don't need it. Okay, so what the law of sines states, the law of sines helps us solve triangles that aren't right. Law of sines states that the ratio of the sine of an angle to the side opposite is constant in a triangle. Okay, so let's break that down a little bit. The ratio, so we're going to have one fraction equal to another fraction. Well, how do we form those fractions? The top of the fraction is going to be the sine of an angle, and the bottom of that fraction, or the bottom of that ratio, is going to be the side opposite of that angle. Okay, and that ratio is always constant. Doesn't matter the angle length, doesn't matter the side. It's always going to be the same throughout a triangle. All right, so that's the word definition. This it's going to make a little more sense visually. So we're given this triangle. We just label it A, B, and C. That part doesn't matter. Remember that side A is always across from angle A, side B is across from angle B, and side C is across from angle C. Okay, so what's the formula for law of sines? Well, you take the sine of the angle divided by the side across from it. So sine A divided by side A. Sine B divided by side B. And sine C divided by side C. Okay. Now there's three parts of that. You only need two of them. Okay, so you're not going to have two equal signs. You only need one equal sign. Okay. So what scenarios can we use law of sines? Well, you always need one angle and the side across from it. Okay, so if you have an angle and you know the side across from it, you could probably use law of sines. Okay. So these scenarios you'll remember from geometry rules. The first one is angle side angle, okay, which means that you have two angles and you know the side that's between those two angles. Okay. So angle side angle is scenario one. Scenario two is angle angle side. So an angle side, you know two angles and the non-included side. So you know two angles, but you don't know the side between them. Okay. That's what non-included means, and that's going to come up again in this next one. And the last scenario is side angle, which means you know two sides and the non-included angle. So you know two sides and the angle that's not between those two sides. Okay. Now there is something special about side angle. Side angle is what's called an ambiguous case. So remember, sometimes in math we do everything right, but we get the wrong answer. That's what happens in this. Okay, let's look at one of each example, one of each scenario. So starting with angle side angle, this one says to find side B. Okay, so let's start by identifying what we're looking for. We're trying to find side B, which is over here on the left. Now remember, you have to know, if you're trying to find a side, you have to know the angle across from it. Or if you're trying to find an angle, you have to know the side across from it. So we have to make sure that we know, if we're looking for side B, we need to know what angle B is. And we do. Angle B is 34 degrees. Okay. All right, so that's going to be part of our problem, definitely. So at some point, we're going to have this equation of sine B, sine of 34, divided by side B, which we don't know. All right, so we need one more ratio. Okay, remember, you only need two ratios. There are three possible ones you could set up. So which one should we pick? Well, we know side A, but we don't know angle A. Okay, it's not listed. Okay. But if you look at the triangle that we have set up, we actually do know angle A. Okay, because we know angle C and we know angle B, and we know that all angles of a triangle add up to 180. So we can figure out what angle A is just by doing 180 minus these other two angles. So 180 minus 80 minus 34, which means angle A has to be 66 degrees. Okay. So we actually do know angle A. And we know side A, so we're going to use that as our known ratio. All right, so we'll set it up. Sine of angle A, 66 degrees, divided by the length of side A, which is 16. All right, now we have a ratio where we have an unknown in the bottom in this case. So if we want to solve a ratio, all you have to do is cross multiply. Okay, so we're going to be cross multiplying on almost all of these. All right, so remember, cross multiplying means we're going to take the top times the bottom equals the bottom times the top. Okay. So we're going to have 16 times sine of 34 equals b times the sine of 66. Okay. Now again, we're trying to solve for b. Okay. So we need to get b by itself. So if we need to get b by itself, we could just divide by the sine of 66. Okay. Now again, with all things in trig, you're going to need to have a calculator handy. But you can punch that all in the calculator all at once. Do 16 times sine 34. Now you would have to close the parentheses. Divided by sine of 66. Again, the calculator will give you the parentheses automatically. Okay. So side B is again just equal to 16 sine 34 divided by sine 66. And you should get a length of B of about 9.8. Okay. Now again, the thing to remember from geometry, the side across from the smallest angle is always going to be the smallest side. The side across from the biggest angle is always going to be the longest side. So 34 degrees was angle B. Side B was 9.8. Okay, well 34 degrees is less than 66. Okay. So we knew that our side length was going to be less than 16. Okay. So again, just take an extra second and make sure your answer makes sense. All right, scenario 2, angle, angle, side. So this one says find the two missing sides. Just for the sake of time, I'm just going to find, let's see, we'll find side T. Okay. All right, so if we're trying to find side T, we have to know angle T, which we know. Okay, you have to know what's across from it. Okay, so we're going to have, somewhere, we'll just start setting up our equation. We're going to have sine of 95 divided by the side length, which we don't know. We're trying to find is T. Okay. All right, so now we have to have some other ratio that we do know. So a side and an angle, the side and an angle across from it that is known. Okay. Well, in this triangle, it's going to be angle R and side R. Okay. We know angle R and we know side R. Okay. So that's going to be our known ratio. Okay. So we'll set it up. Sine of the angle, so sine of 30, divided by the known side, which is 8. Okay. All right, now again, like we said in the last problem, 95 degrees is bigger than 30 degrees, which means side T has to be bigger than side R. Okay, so we should be expecting a number bigger than 8. All right, do the same thing we did in the last problem, cross multiply. Top times bottom, 8 times sine 95. Equals bottom times top, T times sine of 30. And then same thing in the last one. We're trying to get T by itself, so we're going to have to divide by sine of 30. Again, you could punch that all into the calculator all at once. 8 times the sine of 95 divided by the sine of 30. And that's going to give us what T is. So again, if you put that all in the calculator all at once, you should get that side T, and again, we're expecting a number bigger than 8. Side T is 15.9. Okay. Now again, if we wanted to find angle, or side S, which the original problem stated, side S you would just have to figure out, you'd use the exact same, the sine of 30 over 8. but instead we'd have to figure out what angle S is. Okay. Now angle S isn't known, but again, just like the last problem, we know all the sides have to add up to 180. So you would just subtract 30, subtract 95, and you get angle S equaling 55 degrees. And I won't solve it, but I will set it up. If you wanted to find what side S was, now that we know what angle S is, the ratio we're going to use again, we're going to use that exact same one that we knew, sine 30 over sine 8. That was given to us in the problem. So we know that ratio is going to stay constant because that's what the law of sine states. So we're going to have sine 30 over 8. Again, the exact same thing we had in the last part, finding t. But now we're going to use sine of angle S, which is 55 degrees, divided by side S. And then it would be the same thing to solve, cross multiply, divide, figure out what S is. S should be between 8 and 15.9. Again, if you want to pause it and try and figure it out, you can, but I'm going to just write down the answer that if you do this correctly, you should get 13.1. Okay. Well, yeah, make sure you can get those numbers out. All right, and then this last one, the only one that's a little different, this one's side-side angle. Okay. So we know two sides and an angle that is not between them. Okay. All right, well, figure out what part you know, what part of the ratio you know. Again, what we're always looking for is we're looking for an angle that is known and the side across from it that is known. Okay. So we know angle Q, so we know the ratio for Q. Okay. So the setup for that's going to be sine of 98, sine of the angle, divided by the side length. Okay. Now this one says find the missing angle. It doesn't specify which angle to find, so I'm just going to let's find angle R. Okay. So we don't know angle R, but we do know the side across from it. So we're just going to set up that ratio. Okay. Now again, in all the previous problems, we didn't know a side length. So we were solving for a side length. This time we're going to be solving for the angle. So sine of R divided by the length of side R, which is 15. Now the steps are the same. We're going to cross multiply. Top times bottom. So 15 times sine 98. Divided by top, or equals bottom times top. 17.5 times sine R. Now this time we're trying to find R. So we need to get that sine part by itself. So we're going to divide both sides by 17.5. So what we're left with now is we're left with sine R, but currently by itself. And sine R is equal to 15 times sine 98. Divided by 17.5. Now remember, we can't just divide by sine. We're trying to get R by itself, but sine's not a number, so we can't just divide by sine. Instead, remember we do the sine inverse. So we're going to have to take the sine inverse of 15 times sine 98 divided by 17.5. Again, that's second sine in your calculator. And then just plug this whole thing in. And you should get an R value of 58 degrees. And so again, your angle should make sense again. Obviously this was going to be smaller angle than 98 because it can't be bigger. But again, it should make sense. Now we're going to talk about that ambiguous case stuff a little later in the unit. So for right now, just don't worry about that. But know that there are some special things when you're solving side-side angle. All right, and that's about it. Check the site for homework. Have a great day.